Okay, so this is going to be a quick video on port scanning, in particular Nmap, which is one of the most popular tools in any security assessor or penetration tester's toolkits. Now, prior to doing port scanning, it's imperative to understand how network protocols actually work. Port scanners leverage the behaviors of these protocols to identify services, bypass security controls, and gather information. So a base understanding of TCP, UDP, ICMP should be a prerequisite. Now, port scanning is a process of probing a system to discover what services are open and available to the public or its user base. An analogy for a penetration tester would be a thief going to a house and checking the door to see if it's unlocked, then checking the window, then the back door, then checking the chimney. They all serve a specific and practical function for the homeowner, but could also facilitate an infiltration. So a port scan would be the first step in identifying a potential vector an attacker could use to remotely exploit a system. So that thief that checked the windows and doors could find that the chimney is his way to get in. This video will explore some of the different methods of port scanning and some of the implications associated with the techniques. So let's talk Nmap. Nmap is short for Network Mapper. It's a free and open source tool used for network discovery and security auditing. Now, when you first use Nmap, by default, it tries to ping to discover live hosts. So if you type in Nmap in a network segment, it sends out ICMP packets to discover them, unless you're on the same subnet. If you're on the same subnet, it relies on ARP, and ICMP packets aren't sent out. The hosts that respond to the ARP messages or the ICMP replies, those are the ones that are then scanned. So this is beneficial but for speeding up a scan, but could also potentially lead to you missing some systems due to a system not responding to pings for whatever reason, for a firewall or whatever. The ping first feature can be turned off with a PN flag. So let's see here, we can open up, see if I can get a terminal window. So nmap-pn, that turns off the ping first flag. So let's try to do a scan here of a Windows domain controller that I have running in my lab here. So let's first open Wireshark. Okay, we are going to ETH0 as the interface, and I'm going to put in a host filters to only capture traffic sent to the Windows server. All right. So we're now capturing packets. Let me open up a different window. Now I'm going to do an Nmap scan of the SSH port, which is port 22 over TCP. This port is not currently open on the Windows server, so let's see what we get. Nmap. Let's do P for port 22, 192.168.5.101. Now you see the results here. You get TCP filtered SSH. So you come here to the packet capture. You see the ARP request, who has 192.168.5.101 to tell me, and then I get the response, the MAC address. So I know where it is. There's no ICMP packet sent out. Here I send a send request to the server, source port 38687, destination port 22, and you see that there's no response back. Here, let me turn this off so don't get more noise. So then my system sends again. Let me try it again since I got no response back. Source port 38688, destination port 22, no response. Now why is that? So let's go and check the Windows server. What happens is whenever you get a filtered, it's basically Nmap is telling you that I sent out the send request but I got no response. So it thinks that there's a firewall in place, which is the case. If we go and check our Windows server, you'll see that the firewall is running. So I'm going to go ahead and turn the firewall off and run the scan again. me just close this out, close out Wireshark so we have a clean pane to work from. Open Wireshark again. Okay. All right, let's start. So now I'm going to do the same scan again. Nmap port 22 to that host. Now you see that instead of filtered, I get closed. Let's check the packet capture. So here we send a send request to 192.168.5.101. And this time the server responds back with a reset packet because that port is closed. So it's not going to respond. So it just shuts down the connection. So Nmap sees that reset and says, okay, this port is closed instead of filtered. All right, so now let's try to scan. Let's use a UDP port this time. So let's close this. Open Wireshark again. Host 192.168.5.101. Start the capture. So now I'm going to do nmap-su for UDP scan port 164. 192.168.5.101. So now when I send a UDP port or a UDP scan to a closed port, instead of a reset packet from TCP, now we're getting a destination unreachable ICMP packet for UDP. So that's how we're able to tell if a UDP port is closed. So UDP and TCP port scans are fundamentally different because UDP is connectionless. So if you don't necessarily have to get a response back from an open UDP port. So let's try an open UDP port and see what we get. Let's close this without saving. Open Wireshark again. Host 192.168.5.101. All right, so now we're going to scan Snmp. And we see that we have an open port for Snmp. So basically, they sent an Snmp GET request. And instead of getting that ICMP packet back saying that it's closed, it just went nowhere, indicating that the port is open. All right, so now let's try to do a UDP scan with the -A flag. So what is the -A flag? Let's see here first. So the -A flag enables OS detection, version detections, does some script scanning and trace route. So it's an aggressive method of doing some fingerprinting. So it just like it says there, OS version. So let's try add a -A to that. Oh, wrong case. And now we're seeing more traffic. So before where we were just saying GET requests, now we're seeing GET requests, GET requests. We've got a MIB in there too. GET request port map is trying to send all these requests to the system to see what it gets back to try to fingerprint it. And obviously this sends out a lot more traffic than just a port scan. So that's one of the implications of this, is if you want to send a -A, it's for aggressive. So it's going to send out a bunch of traffic, which may or may not end up with you getting detected, but you get a lot more information this way. there we have it. We see that Snmp, we sent a bunch of traffic to it, but we didn't really get much response back. But based on that, based on what we sent, what we saw, we have some best guesses as to what kind of operating system it is. It's guessing that it might be a Windows 7 box with 98% certainty, a Windows 10 potentially with 97%, Windows 2008 97%. So it's a pretty high probability that it's a Windows, but it doesn't know for sure which version of Windows it is. So you see here too that this scan took 112 seconds, whereas opposed to previous Nmap scans, it was, let's see what it says here. This one was 0.49 seconds, 0.51 seconds, 0.49 seconds. So takes a lot longer, especially that it's UDP. So a lot of the packets just have to time out because there's no response. But so you can see the difference there. All right, so, and again, because of all this extra traffic, you learn more about your system potentially, but you could also potentially be detected. So let's try the same thing, -A. Let's not use a UDP port. Let's use a LDAP port and see what we come back with. So now this scan was a lot faster than the previous one. We get 3 seconds. Let's try 3389 and 88. Oh. Let's try 3389 and 88. '88 is a port for Kerberos, and 3389 is a port for remote desktop services. The system should be listening on both of these ports. All right, so this time it comes back and tells you that Kerberos is open. It tells you remote desktop is open. It also complains that it's unreliable because it didn't find one closed port as well. It uses both open and closed ports to do its OS fingerprinting. So, but this time it's a lot more confidence in what it's running. It knows that it's running Microsoft Windows version either 7, 2008, or 8.1, which it is. This is a Windows 2008 server. And I think it's pulling that from the, probably Kerberos, I'm not sure. But it's a lot more confidence. That's not even giving you percentages. It's telling you, yeah, this is what it is. And it's right. Okay. So let's try to do, I'm going to go ahead and close out of Wireshark here. All right, so I want to show you some scans via for greppable output. So when you do an Nmap scan, you can pipe the output out to a file. You can pipe it to a text file, or you can give it an XML, or you can give it what's called greppable. So let's do that. I'm going to do an Nmap scan for port 80, which is web. 192.168.5.0. I'm going to do the whole subnet. I'm going to turn off, no, I'll leave ping on. And greppable output is OG. I'm going to pipe it to a file called web. Internal sweep.txt. So this scan is going to try to discover all 254 network addresses on the network. It's going to look for everything that's alive and if it's listening on port 80. So now let's take a look at the internal sweep.txt file. So it output its findings into this file. Not great read. You see some stuff is up, you see some stuff is closed on 80, some is filtered, some is open. So let's try to do, let's just grep it. So let's grep everything that's up. We're going to look for files that are, or systems that are up. So up, internal sweep.txt. Okay, we see these IP addresses are all alive. So now let's just see which systems have port 80 open. Grep open internals. Okay, so these 4 systems have it open port 80, but it's not really, still not great to read. So let's try grep open internal sweep, then pipe, and then cut -d 2. All right, so now we want to just see the IP addresses of all the systems that are listening on port 80 on the subnet. So it's handy to be able to pipe these things into files if you need to send them to other tools to try to parse out what you want to do, or if you are running a script, so you discover which systems are up and open, and then that automatically launches another script. So very powerful tool. So I also want to mention the Nmap scripting engine. It's one of the Nmap's most powerful and flexible features. It allows users to write and share simple scripts. It uses the Lua programming language, and it automates a wide variety of networking tasks. So those scripts are executed in parallel with the speed and efficiency you would expect from Nmap. Users can rely on a growing and diverse set of scripts distributed with Nmap, or you can write your own scripts to do your own custom needs. So let's take a look and see if we can find, I always forget the location of all the Nmap scripts. The Nmap scripts have .nsc as the extension. There we go, user share Nmap scripts. So ls user share Nmap scripts. These are all the different modules that basically ship with Nmap. So they have commands for SMTP, SMB, HTTP. There were some Metasploit modules I saw there. All these different things come shipped with it. So the system we were scanning before is a domain controller. So let's try a script for the SMB service. So nmap 192.168.5.101 -- script, and then you just put in the name of the script you want to run, OS discovery. And there we go. So by running that script, it automatically starts looking for open ports that are associated with Windows SMB service. So it's looking for DNS, Kerberos, RPC, LDAP, kpassword, all this stuff it just looks for. And then it tries to enumerate it. So from OS Discovery, it's able to pull out the exact version of Windows it's running. Before we were just saying, we went from having a 97% confidence that it was Windows 2008 to knowing that it was either Windows 7, Windows 2008, or 8.1, and now we know exactly it's Windows Server 2008 R2 Data Center, and it gives you the service pack as well. It gives you the computer name, it gives you the domain associated with it, it even gives you the system time. So these are the kind of things that you run through with Nmap. You start off high level, and then you can add on more specific ports, more aggressive scanning. It gives you a higher level confidence of the systems that you're dealing with. Once you figure out to the certain port, okay, well, I know I'm running some kind of Windows services. Now I can run the OS SMB discovery script, and now I can see much more information than I had when I started with. So that's the power of Nmap and the first step of doing active discovery.